actually traveling through some tunnels. Actually, it guides to a tunnel after 2 hours. If you chooses road 3, after walking 3 hours, you will actually return back to the tunnel. And if it chooses road 3, after 5 hours of walking, you will return back to the tunnel again. Question is, what is that? Expected length of time until the miner reaches safety. Is get rid of. So, we assume that a random variable will exist. Right? When it is what? Idea of the load that the miner chooses. So we have y equal to what? What are the possible values of y? And the PMF? Right? Now, once we have this, given y equal to 1, what is the expected time that it needs? Let's say x is the expected length of time. Then our goal is to find out x, right? We are interested in calculating expected value of x. So E of x given y equal to 1. What is it? If it chooses to do 1, then what is the expected time it needs to do 2 hours? If he chooses to do
3 hours.
after 3 hours he comes back to his original place and still he can choose to do since it is equal. So it will be 3 hours plus expected. And finally if he chooses 3, it will be 5 plus. Right? Then, what is the expected value of x? The total expectation. For all values of y, what we need to do? Should be multiplied with the PMF of y. Right? This is the law of total expectation. The expected value now, this equation can be translated into expected value of x given y equal to 1 times PMF of y for the value 1. Is it okay? Plus expected value of x given y equal to 2 times PMF of y for the value 2 plus expected value of x given y equal to 3 times PMF of y for the value 3. Okay. Now, PMF of y for all values of y is right. What is this expected value of x given y equal to 1? 2. What is this? 2 plus expected value of x. Right. And this one is 5 plus. Then it will be we will get 3 expected value, and in the right hand side we have 2 expected value to cut 3. Then this expected value of x is what? This problem is actually very simple.
Sir, now there is 3 expected value of x.
Which one?
First one.
This one? This 1 over 3 in the left hand side becomes 3, right? Just give different from actually follow it that. It's okay. Now, this problem can be tweaked. Let us say we have hey, you come here. Right? And from the next class class you will be sitting here. So, this problem can be used. Let us consider a bit intelligent minor. Whenever he chooses the door, he wants it. In case he returns here, he will not choose the door again. Then, will the expected value change? Try to solve it. Is the problem clear? We have now an intelligent minor. When the minor chooses one door, he marks it. Next time, if he comes back to the minefield again, he does not choose that way. So when he goes there, he knows that he already explored that route, so he will try other routes. Here is the answer. And there are very sophisticated problems. Very sophisticated. In previous year's questions, you will find some very sophisticated. The mean of a geometric random variable. You know what is geometric random variable? If we toss a coin repeatedly until the first hit, and we count x as the number of tosses, what type of random variable it is? Anyone following me? If you do not follow me, then I can just not follow the slide. Or even better, your friends from section 1 has the photograph. So, if we assume that x represents the number of tosses until you get the first head, then x is geometric with parameter p. This is the probability of it. And then this PMM is this one. We know that. Calculation of the expected value of x actually requires the use of an infinite summation, right? So, sum of infinite series. And actually, after a long fighting, you will end up with the value. Let's see how simple is it. Let us assume, I think you already noticed that to apply the law of total expectation, what you need? You need two random values, x and y. Even if y does not exist, you can assume it. And you want to calculate the expected value of x, what you need to know, what is needed to be available there. The expected value of x given y somewhere. If you know the expected value of x when some values of y is given, and if you get it from all values of y, then you can calculate the expected value of x applying the law of total expectation. Subject to the fact you know the PMM formula. Now, here we want to calculate the expected value of x. We assume a random variable y, arbitrary, and see the intelligence here. Y has a value 1 if the first toss result in a hit, and y has a value 0 if it is a hit. I think you already noticed one more thing. What is that? The value of this random variable y is not related to the result. You can have here 100, 200, and 300. Is it okay? Because you just need what is the probability that y has a particular value. You are not dependent on the exact value of y. That's what here, let's assume y is 1 or 2. You can assume 1 and 2. So, what y represents whether the first toss produces any head or not. Then, so if y is equal to 1, what is the expected number of tosses that will be given? If y is equal to 1, then what is the expected? Because If y is equal to 1, that indicates what? First field produces a. So this one is always 1. And if y is equal to 0, this is sort of recursive things, right? The law of order expectation is some sort of recursion. You will keep repeating until you are here. Once you are here, you will be ending the recursion, right? And once it is there, then what is the expected value of x? Expected value of x is expected value of x given y is equal to 1 times this. Hello? Hello? Yes, I can go there. Academic terms of the academic শেষ করতে পারবেন? ঠিক আছে? ঠিক আছে, ঠিক আছে। Sorry. So, I will finish the class in 10 minutes then. You know, I can finish it. So once this is the case, so what is the PMF of y? It is P where y equal to 1. It is 1 minus P when y equal to 0. It is 0 otherwise. Then this one is multiplied by P and this one is multiplied by value of this one is 1, value of this one is 1 plus from here. If you put all these values here, then you will find that Ex is equal to P plus 1 minus P Ex this and so this gives you two things. One is you can calculate the expected value by conditioning the expected value on another random variable. Really easy. Just solving some different equations. Second thing is that you do not need to know the probability model to calculate the expected value. That means you do not need the PMF or PDF. We are solving the expected value of x without knowing the PMF of x. Right? Now we move on to the continuous case. The continuous case is very simple. What is the simplicity? Right? Let us be on this. This one, the first one is the PDF of x given a, particularly x will be the PDF of x divided by what? Probability of that means here the PMF will be replaced by PDF. This PMF will be replaced by PDF of x. Now if we come here, any volunteer? It will be the joint PDF of xy divided by marginal PDF of, right? The joint PDF of x and y will be the conditional PDF of x given y times marginal PDF of y. The law of total probability has summed the PDF of x integration of the conditional PDF of x multiplied by the PDF of y. The addition will be replaced by here we have addition, here it will be multiplication, right? And finally, we'll see it tomorrow. Two random variables are independent if their joint PDF is equal to the product of the individual PDF of all terms of x. though it looks a bit hazy or busy, but do you understand? We can just finish it. But how will I cover 9 classes? It is 21st class, right? According to the records. How can we cover 9 classes? We have 2 weeks, right?
Yes.
4, tomorrow 5. Still? At least you should allow me 1 or 2 classes. Okay. Now we understand why those 3 classes actually have gone. 1, before the and this here equation we find that. Second, the Independence Day. By the time, maybe we need to have a class on next Wednesday. All the weeks, actually, I have been busy with this course. Right? Taking 3 or 4 classes is not easy. Anyway, we have seen this formula. What does this formula do? Actually, if this is the PDF of random variable x, then when we actually have condition on that a to the a to b, x will then actually just increase by a. So now I ask how I do class A. Class A. আমি ক্লাসে আসলে বড় নম্বর what I am thinking actually feeling all the time that I am taking classes and repeating the same thing again and again and again. So this example is a very good one. Though my memory says I discussed this one with you, but the other section denied it. The exponential random variable is memoryless. Did I discuss it in this class? My memory says I discussed it, but the other section denied it. So let us consider. What does this diagram mean? Diagram says this is the time axis. The downward arrows indicates the arrival of a bus. And these are time between 2 successive arrival of bus. Bus interval of times. Now you and here. You arrived at the bus service after the arrival of the previous bus, right? The bus has already departed. After the departure of the previous bus, with the delay of time, T. So before you came, 10 minutes earlier, the previous bus actually left the bus system. Now, the time that you need to guess the next bus is X. Is the problem scenario? We assume that T is exponential with parameter. For example, if lambda is equal to 3, that means every other 20 minutes there is plus 1 and minutes. Right? Average interval time is 20 minutes. Now you have the laptop open. You have the laptop open. Is it possible that you will actually move the fan in front of you? So T is exponential with parameter laptop. Now, what we want to know that at the time you arrive at the bus stoppage, event A occurs. And what does event A says? T minutes already been passed. T is already greater than T, right? And T actually starts from here and it goes up to here. It says the internal time. Now what we want to calculate is probability that x is greater than x given that event A occurs. This probability will eventually prove that exponential random variables are. Before that, what do we mean by the term a random variable memory test?
It's reset. So
Yeah,
it doesn't depend on the previous waiting time.
Does not.
Depend on the previous মানে এখানে যেমন এই কি সময় যে ওয়েট করছে সেটার উপর ডিপেন্ড করবে না সে যখন থেকে আসছে তখন থেকে তার ওয়েটিং পিরিয়ড স্টার্ট হবে
So, it's speaking English. You have your international flights.
So basically it doesn't depend on the waiting time the work is
Does not depend on okay. Any better answer? Actually, it forgets the waiting time. Who asked the movie does the right time? No. So it does not have a memory and cannot remember things. Actually, now just consider as soon as the last bus left, one of your friends arrived at the bus stop and you arrived 2 minutes later. Both of you will catch the same bus. So when you arrive there, then now you and your friend are waiting for the same bus. So waiting time, remaining waiting time for both of you are set, right? And the probability should be same. That after 10 minutes you will catch the bus, after 10 minutes you will catch the bus. So this probability should be same for both of you. And this will only happen when actually your friend forgets his waiting time. Otherwise, what will happen? If you do not actually be present there, then his waiting time will be depending on what? Starting from that time, actually. Always the waiting time will depend on the current. Whatever time has already been lost, the probability of arriving a bus after a certain time will only depend on the result. And that's how actually the random variable will forget its bus. Let us see it mathematically. So we want to know the probability that x is greater than x given A. Can I write x is greater than x and t is greater than t plus x? Can I write? Okay. X is greater than x, right? If I add t on both sides, can I write this? The x plus t is what? So x is greater than x also implies capital T is greater than t. Given that t is greater than, now if you assume this is A and this is B, then what happens? This is the conditional probability of A given B, right? Equal to what? The joint probability that t is greater than t plus x and t is greater than t. Is it okay? Divided by what? Probability that? Can I write this? Simple formula, the probability of A given B is equal to what? The joint probability of A divided by probability of B is this one and A is this one. So joint probability of AB means probability that T is greater than T and T is greater than T plus X. Now, this one is the joint probability means what? Intersection, right? Joint probability means intersection. Now, among these two, which one is common? Is that what should be here? 2, 4, 6 and 4, 6. which one is a subset of the other one? This one is a subset of the first one. Among these two, that means t plus x, t is greater than and t is greater than t. Which one is the subset of the other one? T plus x is greater, t is greater than t plus x. Is subset of t is greater than t. So the second one is subset of the first one. Agree? Why it is not? Let me draw the time diagram. This is t, this is x. When we write t is greater than x plus t, it starts from here and it goes up to, and when we write t is greater than t, it starts from where? Which one is the subset? So this is not true. This one is a subset of this one. And if this is the case, then we can write probability that t is greater than t plus x divided by probability that t is greater than. Can I write this? If this is the case, we are here, right? For exponential random variable, it's severe. Can anyone tell what is it? Right? So, and this one is what? If probability that x is less than x equal to 1 minus e to the power minus lambda x, then what is it? E to the power minus lambda x. If the probability that x is greater than x is e to the power minus lambda x, then from here, what we can write? Probability that t is greater than t plus x is equal to e to the power minus lambda times t plus x, and in the denominator we can write e to the power minus lambda x, which actually is e to the power minus, right? Lambda t, which is equal to lambda x. So this probability is, what is the distribution? This distribution is exponentially. So now what we can conclude from here, the arrival time of the next pass depends on what? If it is exponentially distributed, then it only depends on the mean. That's why only x is here. It does not depend on x plus t. That's why the exponential random variable forgets its past. Like what? If the average lifetime of the bulb is 6 months, after 6 months it will still remain its average lifetime 6 months. And the probability that it will last 1 month or 2 months or 1 year will still remain same as if it is reborn. Because always it forgets its past. That's why the exponential random variable is so simple and easy to deal with. Most of the cases, whenever you go for an analytical analysis, you will always actually try to somehow assume that it is exponential. Integration is easy, differentiation is easy, and it forgets its past. The time parameter always, you do not need to consider how much time it already has elapsed. You just need to consider what is the result. Okay? Now, let's consider this one. Suppose the duration t of a telephone call is exponential random variable with parameter 1. That means t is exponential with lambda equal to 1. Right? So its PDF is We know the PDF is lambda e to the power minus lambda x or lambda t. Then lambda is 1 over 3 e to the power minus t by 3. For all calls that last at least 2 minutes, at least t is greater than 2. What is the conditional PDF of the coordination? The PDF of the coordination is exponential with this distribution. Now we want to know that an event A occurs, that now we are considering some calls that are at least 2 minutes. So you need to find out the PDF of the call, the given that T is greater than 2. Do it. Since people are sleeping, do it. Put no message. Business. So nowadays the students are in sometimes pretty students become excited. Itu what bonus. You have both, right? What? Same? No, it will not. Because the conditional PDF is the unconditional PDF divided by probability of A. If you claim that it will remain same, the probability of A, that is probability that E is greater than 2, has to be 1. But it is not. According to your claim, the probability, what is even A here? E is greater than 2, right? So if the PDF remains same, then probability that E is greater than 2 has to be 1. And a probability will only be 1 when it will cover the whole sample size. But it is not, because it is excluding the calls that are less than 2 degrees long. So it cannot be 1. And if it is not 1, then the answer is not 1. Right? Don't actually confused with the numbers. Actually, I was trying to write a lecture note few years there, not now, but the last few years there. In fact, after the COVID-19, then actually it was chapter 6, example 21. I tried to combine examples, text from different books, so that I can follow my lecture. Eventually, after writing around 200 pages, I gave up. So anyone solve it?
0.257.
But you are actually calculating the probability that T is greater than 2 by summing. It is not 2, 3, 4, 2.1, 2.10, 2.11, 2.12, 2.13. A call duration could be anything, right? It is continuous, right? Call duration is not discrete. It will be for what? Tell me that. Tell me what? It will be for what? It's okay. Because remembering that one is very difficult. Probability of A is probability that T is greater than 2. Which is, how can you calculate a probability for continuous random variable? 2 words. from senior, from critical. So usually we prefer from critical. From 2 to what? Infinity. What do we need to do? We need to integrate the critical. Right? 2 to infinity. What is the value of ft? 1/3 e to the power minus 1/3 t. Right? dt. Is it okay? And then 1/3 minus 3 e to the power minus 1/3 t 2 to infinity. Is it okay? Then when you put infinity here for t, this becomes negative infinity and this becomes. When you put 2 here, this 3 and 3 cancel out each other. We have what? E to the power minus 2 by. You got this one? 0 point something is this? Now, what is the conditional PDF of t given t is given a is what? The unconditional PDF of t divided by probability of t, which actually is 1/3 e to the power minus 3 by 3 divided by e to the power minus 2 by 3, which actually is 1/3 e to the power minus 3 minus 2 by. Is it okay? There is a typo here. This formula is taken from the text. Any confusion here? Any confusion? Why? What is the problem? You ask me. But you did the same thing but got different result.
I got the result of the already process.
You can get the same result in very different ways. What you can do? So how do you prepare? So you subtract. It is working here, but it is not the case that it will work all the time, right? It is working. If we condition on another random variable, as you already have seen, the joint PDF, so a conditional PDF of x given y will be what? The joint PDF divided by marginal PDF of the other random. If you calculate it for x, then you have what? Actually, this random variable will be always b will be there. A given b, b will be there, right? This is the no problem. Solve it. So before we go here, one thing that actually we want to recall from here, if we want to calculate the conditional PDF, then what should be available? You can calculate the conditional PDF of one random variable or conditional PDF of one random variable. If the joint PDF of both the random variables are available, as well as the marginal PDF of the other random variable is available, right? So whenever a problem is there, you are asked to calculate the joint probability. You need to first search whether the joint. Since you are asked to calculate the conditional probability, then you need to search. Joint probability should be there, and the marginal probability of the other random variable should be there. Now, joint probability is available, we can always get the. So if we know the joint probability, then we can calculate the conditional probability of any of these two random variables. Is it clear? Because to calculate the conditional probability, you need the joint probability and you need to divide the joint probability by the
Marginal.
conditional probability the other. And from the joint probability, you can calculate it. So from here, is the joint probability given? Is it given or not?
Yes.
What is it? Two? Yes. Why?
Yes.
Why? There are many students here. Why is it? Because these two random variables are uniformly distributed in an area, in a region, defined by this. We have seen this on many times, right? Right? 0, x and y are within 0 to 1, but y is always less than.
X.
So we are considering a triangle that is below the line, y is equal to x. So the square of one unit length is 1. We are considering half of this square. So the area defined by this limits are half, and so the PDF is density is order of equal to 2. So from here we can easily write the joint PDF of x and y equal to right? Now we want to calculate the marginal PDF of conditional PDF of x. To calculate the conditional PDF of x, we need to divide the joint PDF of x by what?
Marginal PDF of y.
So your job is to calculate the marginal PDF of y. Do it.
1 by 1.
The marginal PDF of y equal to how do we calculate the marginal PDF of y? By integrating the joint PDF from all. So the formal equation is right? Then this is 2, right? What is the limit?
0 to 1.
1 to 1. 0 to 1.
The limit is from 1 to 1.
We want to integrate it for all values of x. For we have y here, x here. For a particular value of y, x is
1.
from y to how many times we have been using this diagram, right? So there should be a question of
Yes, sir.
there should be a question that is related to or similar to this line. You can consider many different. Right? There are many possibilities. As except this one for this, and this, the PDF is, but the CDF will be different. Yes? So the conditional PDF of x given y, the joint PDF of xy the marginal PDF of y, this is 2 divided by 2 into 1 minus y equal to what is the distribution? Can anyone tell? This is what we use this symbol to represent the distribution of whatever we have done. That is it. So we want to know the distribution of x, which is conditional on a particular value of y equals to 1. So the conditional distribution of x given y is, can anyone tell? Mathematically it is this, right? What type of distribution it is? Exponential? Uniform? Okay, uniform. And what is the rest?
The rate is I go y from b to x, so it will be from y to
Right? Because if it is 0 and it is 1 and y is here, it is uniformly distributed here. And the length is what? 1 minus y. Right? What is the interval of this? So, x, conditional x is distributed in between y2. That's why, since it is uniform, its distribution is 1 over interval. That's what we have been telling since the beginning. Right? So, yeah?
How do we determine the degree of yeah? That's the
This is uniform. When x and y are jointly uniform, that means, actually, if you consider the PDF curve, here, the PDF curve will be along the z-axis. This is y, this is x. PDF curve will be, right? And the shape of the PDF curve will be something like this. Half of this step. And it is same everywhere. Now, why is 1, why to 1? Because, now if you focus here, once you set y equal to 0, what is the limit for x? When you set y equal to 0.5, x is still 1. And it is still uniformly distributed. That's what is here. Now your job is to find out the following the same process, you can do it, right?
Uniform from 0 to x.
Do it. So what is the marginal distribution of
2x.
x? 2 calculated, huh? 2x. 2x?
1 by
2x or 1 by x?
So 1 by
What is the marginal distribution of x?
marginal is 2x.
So 2x. You need to calculate the marginal distribution of x, then you will divide the joint PDF by the marginal. The joint PDF is 2, marginal PDF is 2x, then the condition of PDF will be
1 by x.
and it is uniform in between 0 to 0. Right? Everyone understand? Yes? So we can discuss. Yeah. The marginal distribution of x is 2x. And so the condition of PDF of y given x is. We'll come back to this problem again. For now,
340. 340.
You want to go? When did you start? After the exam, we had a break. I had a break. Did you start at 2:30? When? 2:50. If it is 2:50, then we can walk to 4 or 5. And the bus will still be here. Right? There is no shortage of beef. There is no hurry that the bus will beef. Right? Hmm? What is it? That was it. Was there any class of the ninth?
Except with
Sorry?
We had a quiz.
quiz.
Tomorrow?
Quiz is a big.
Quizzes. Most of the students do not do anything for school. If they have a good mood, they come. If they do not have a good mood, I think you thought that the quiz scripts are not examining, right? Example. So those who actually does not appear get 0. If someone appears, the 5 marks is good. Most of the cases. Unless the script is empty. How could you get 20 out of 15? Upper limit is always there. And if you solve the problem, but in the opposite direction, even so which is important. That's why my grades follow except the last test. Last test is the test that is within the not the last test. They have exceptionally good 20 or 25 students and exceptionally poor 20 or 30. And the distribution is not wrong. So this one is also applicable for right? Solve this problem. First a point is selected in between 0 to 1. Let's say the distance of the point from 0 is 1. Right? So a point is selected so that the distance is 1 from 0. That point is selected. Then the second point is selected randomly in between 0 to white. You understand? We have a line from 0 to 1. First, randomly, uniform randomly, we choose a point, and the distance from 0 to this point is white. This statement is a little complicated, but it is there. Now, in between 0 to white, you choose another point. Still following the same process, uniformly. X. Now, you are asked to calculate what? Okay, this is the second step. Solve the first step first. Let's say this is problem number 2. What is problem number 1? This formula is related to joint probability.
Section 1.
Find the who can solve it?
Section 1.
Joint probability. Very simple one. One by y. One by y. that slide. Go to that slide. ছবি যেগুলো আমরা একটু ছবি দেখার পর দেখবো যে এত ছবি there are so many figures সে thousands but no to be honest still not recall everything you cannot recall a particular figure so anybody got 1/y here as I mentioned for the discrete case, when we calculate the joint probability, you can use either of the two formulas. The conditional probability of x given y can be multiplied with the marginal probability of y, or the conditional probability of x can be multiplied. Sorry, conditional probability of y can be multiplied with the marginal probability of x. Question is, which one? As we discussed at that time, the independent one will have the marginal probability because you can calculate the marginal probability without considering the other. Here the marginal probability of x is given or marginal probability of y is given. Because y is uniform in between 0 to 1. 0 to 1. What is the PDF of y? PDF of y. 1. Y is uniform in between 0 to 1. So, the PDF of y equal to 1 for y in between 0 to 1. And conditional PDF of x given that we do not have option. If the marginal PDF of y is given, then we need the conditional PDF of x. Is it given here? X given y equal to y is what?
1/y.
This distance is y. Once you choose the point here, then the second point is to get uniformly in between 0 to y and the length is x. So it is uniform in between 0 to 1. So the conditional PDF of y given x given y will be what? And the joint PDF will be the product of this one and this one. This is too good, right? Example. Example says the marginal PDF of x can be calculated from the conditional PDF of x and from the marginal PDF of y. So from here actually, once this one is given and this one is given, we can calculate the marginal PDF of x. Do it. Can I calculate the marginal PDF of x? Joint PDF is the multiplication. Marginal PDF is always considered, always try to remember in terms of the matrix. The marginal PDF is the sum of the rows or sum of the columns. Here it will be integration with respect to y. Right? So the product of the conditional PDF of x given y and the marginal PDF of y will be integrated with respect to. So the values are, we know the product, right? The product is what is the limit? Once again, you need to draw the diagram. The diagram is interesting. Y is along the x-axis, right? And x is along the and y can particular value of x, y goes from x to 1. And what is the result? Right? Log natural 1 minus log natural x equal to log natural Now you understand the marginal PDF of x previously this was here marginal PDF of x was 2x. When you change the axis it becomes minus 1x. An example is given here. Here it is. What is this? Okay, solve this one. So many things. Okay, let me finish it quickly. Okay, this one. Can we solve this? The PDF of random variable x and y given x are given. Can we find the joint PDF? Of course, by multiplying. Can we find the marginal PDF of x? Sorry, y? Of course, by integrating the product with respect to y to 1. Pushing it y is y to 1. Y to 1? Why the limit is y to 1? Can anyone explain? Since 0, y, that will have been. The only thing that is scales is now this 2 has been replaced by right? So conditional expectation we have seen for the discreteness, here it is said. For this problem, we have already seen the conditional PDF of t given this is minus, and if we calculate the expected value of t given t is greater than 2, what it will be? From 2 to t, from 2 to infinity, we will have the t times the conditional PDF of t given t. Right? Just the distribution will be replaced by the conditional distribution. Now it will be what? From 2 to infinity t times 1/3 minus 1/3 times t minus 2. Right? Can we solve it? How many of you solve it? If you cannot solve it, high marks from today's quiz will be deducted. What is the challenge here? The limit is given. This time limit is not the challenge. This time the challenge is integration by right. So integration by parts or setting limits, either way will actually take in the test. It will be a shame, right? If you cannot compile this sum. Because it's past tense, sir. I have no longer past tense. Anybody has any clue? What is the equation?
Integration of u dx.
I am not solving it. It will be u
Integration p dx minus
Well, iPad-এ চার্জ 1% accuracy
পাওয়া যাচ্ছে না, গুগলও পাওয়া যাচ্ছে না ফর্মুলা।
চার্জ কিভাবে সার্চ
formula we get into BI control is part of the formula.
গুগলও পাওয়া যাচ্ছে না। So this is the formula and you can solve it right here. Anyways, you can calculate it for a function, just x will be replaced by the function. What is it? Let us finish here. For random variable x and y, the conditional PDF is given by this one, right? We have already seen this. And if you are asked to calculate the expected value of x given y, then only challenge is what? X multiplied by the conditional PDF that we get from here, or setting the limit is the challenge by 1, and then if homework is given to you, tomorrow morning I will ask someone to calculate the expected value of x by applying this doing this one for all values of y will give you the, and you will check it by directly solving it. What is the original original PDF of x? Can anyone recall? So you can calculate the expected value of x from here as well. Expected value of x. Axis. Oh, 2x. Sorry, my mistake. 2x, not 1 x. So 2x, dx. And this result should be. So we finish here.